What is up, everyone? It's Mr. Lang. In this video I'm going to be taking you on a review of combining like terms. So all you need is your notebook and a pencil and you are good to go. So let's get started. Alright, this phrase, combining like terms. You've been using it for a while. What does it actually mean? Well, there's kind of two parts. There's the combining part, which means adding and subtracting. Combining is not the greatest word mathematical wise, but adding subtracting is. So that's what it means, adding and subtracting. Now, like terms, you kind of have a feel for what that means, but let's define it. Like terms stands for terms that have the same variables and powers. So, just kind of quickly here, you know that if you have something like x plus 4, x and 4 are not like terms. You cannot combine them. The best you can do to simplify it is just leave it like this, x plus 4. They're not like terms. It's the same thing with powers, even with the same variable. So if I had like x to the third plus x squared, I can't combine these. X to the third and x squared are just as different as an x and a 4. We can't combine these, so these are not like terms. What I want to do is go through some quick examples and then we'll get to kind of more meaty examples. So let's hit the quick examples first. Alright, some quick examples here. Might want to pause it to just copy these ones down. We've got 6 plus 3, 4x plus 3x, 6y squared minus y squared, and then 10x squared plus 5x. And what we want to do is combine the like terms. So let's take a look. Well, 6 plus 3, obviously, these are like terms. We can combine them. We've been doing this forever. 6 plus 3 is 9. All right. Similarly, 4x plus 3x. They've got the same variable, x and x, and the same power. Really, it's x to the first and x to the first right there. So 4x's plus 3x's gives you 7x's. No problem. 6y squared minus y squared, well, it's really 1y squared. And it's the same variable y. It's the same power too, so we can combine these or subtract them. So 6y squared minus 1y squared gives us 5y squared. And then finally here, we've got 10x squared plus 5x. Now it's the right variable, x and x here, but they have different powers. It's squared into the first. So we can't combine these. This is a trick question. Our answer is really just this itself. We can't combine. Alright, so those are some quick examples. Let's actually get to some ones like you would actually see on a homework or test or quiz. Alright, example number 1. We got 5x minus 7 minus 3x. Not written in standard form. Things are kind of just all over the place. So what I like to do, let me get to my blue pen here. What I like to do is circle my like terms, the ones that I'm going to start with. So I'm going to start with the 5x here because I see that there's a positive 5x. And I also have a negative 3x. Make sure you circle whatever sign is in front of it as well. Well, I know 5x minus 3x would give me 2x. And then I'm left just here with this constant minus 7. So this whole thing is going to simplify down to 2x minus 7. Notice we're not solving this, we're just simplifying this expression. So that's an easy one, example 1. Example 2 is y plus 4 plus x minus 3y minus 1. So we're actually dealing with two different variables. We've got x's and y's here. So I'm going to start with the x's, I guess, and I only see one x term. That's this positive x. So I'm going to start with that. I've got a couple y's here. I'm going to box them so it looks a little different. You might have seen teachers in the past do this kind of thing. We've got 1y minus 3y, so that would be minus 2y. And like I said in class, I don't want to see this like plus or minus. I just want minus 2y. And then we get down to the constants. We've got a positive 4 and a negative 1. That's going to give us 3. So our simplified version of this messy thing is x minus 2y plus 3. Now, if you started with the y's, then your answer would be negative 2y plus x plus 3. And that's perfectly fine. Doesn't matter if you start with the x's or y's. Alright, next example. Example 3. 2x squared minus 4x plus 5 minus 3x plus 8 plus 4x squared. A real mess here, but we do only have one variable, which is x. So what I like to do with this is start with the ones with the highest degree or highest exponent. So we've got a positive 4x squared here, and I've got a positive 2x squared here. That's going to give us 6x squared. We've got a negative 4x and a negative 3x. That is going to give us negative 7x. And then we got our constants, 5 and an 8, which gives us 13. And there it is. And this is in standard form too. What that means is that the powers of the exponents go in descending order. So they start big with the squared, then to the first, and then this is the x to the 0, but it's really just a constant. All right, example 4. We've got y to the 5th plus 4y to the 4th plus 6y to the 5th plus 3. It's getting kind of higher up in the exponents. Well, we'll start with the fifths. So I've got a 1y to the 5th here, a 6y to the 5th here. That's going to give me 7y to the 5th. I've got a 4y to the 4th here, and that's positive. And then I'm left with just this constant plus 3. So that's going to be my final answer, 7y to the 5th plus 4y to the 4th plus 3. No problem. We got 2 more examples, and we're going to bring in the distributive property with these. So example 5 is 4 times the quantity 2y plus 5 plus 10. And we want to simplify this. So whenever you see a chance to distribute here, do that first. So it's going to be 4 times the 2y and then 4 times the positive 5. So let's start here. 4 times 2y is 8y. So I'll put an equal sign here. 4 times 5 is 20. And then we've got the plus 10. Now we can combine like terms. You don't want to do it before. So really the only terms to combine is the 20 and the 10. That's a 30. So the most simplified version of this is going to be 8y plus 30. No big deal. Nothing tricky there. Alright, example 6 though does have a little catch to it. Example 6 is 6w squared minus 10 times the quantity w squared plus w. Alright, and I want to distribute first, but you got to figure out, well, what am I actually distributing here? Well, since this is a minus 10, we are actually distributing this negative 10. It's a negative 10. We're multiplying it times the w squared and then times the w here. So I'll give myself a little room here. Don't forget the 6w squared. But negative 10 times w squared would be negative 10 w squared. And negative 10 times w would be negative 10 w. Alright, so that's the big catch there, is that you're distributing the negative 10 to both. Alright, now I'll combine like terms, and the only ones I can combine are the 6w squared and the negative 10w squared right here and right here. So that's going to give me negative 4w squared minus 10w. Alright, so those are your 6 examples, a bunch of examples with combining like terms. So let's get to the SIA questions. I've got 5 of them here for you. You know the deal. Do these on your own and then go on to Schoology and enter your answers in. So I hope you enjoyed this video. Thanks for watching.